In the heart of our solar system resides an unlikely killer, one that gives life but can also destroy it. Our Sun, the glowing beacon of warmth and vitality, holds within it a raw and untamed power capable of shaking Earth's technological foundations. History has already shown us a glimpse of this devastating potential. Back in August 4, 1972, during the tense days of the Vietnam War, U.S. Task Force 7 aircraft were flying reconnaissance missions off the coast of North Vietnam. Everything appeared normal, clear skies, calm waters, until chaos erupted. In mere seconds, 20 to 30 underwater explosions went off in Haiphong Harbor. These weren't enemy attacks. The cause was baffling. The mines planted there were part of Operation Pocket Money, a strategic U.S. naval effort to blockade North Vietnamese maritime routes. These magnetic mines were designed to detonate when triggered by the metallic hull of a passing ship, disturbing the magnetic field. But no ships passed overhead. So why did the mines explode? For over 40 years, the answer remained a mystery. That is, until recently, when declassified U.S. Navy reports unveiled a shocking culprit, not of this Earth, but from above. The Sun. This revelation reframed everything we thought we knew about space weather's impact on military and technology. Solar activity, often underestimated, had enough force to trip underwater munitions. This unprecedented event set scientists scrambling to understand just how far solar storms could reach and how deadly they could be. Historically, the Sun has been both worshipped and feared. To the ancient Egyptians, it was personified by Ra, the sun god, depicted with a falcon's head and a solar disk resting on his crown. Ra symbolized the giver of life, warmth, light, and nourishment. But he also carried a darker side, one of destruction and wrath. His eye, in the mythological texts, could manifest as a fiery lioness to scorch the earth when he was displeased. This ancient allegory is eerily resonant in our modern age. The Sun, so essential to life, still holds the power to unleash catastrophe. And today, that risk is higher than ever. We are currently entering solar cycle 25, a period predicted to be more active than its predecessors. Scientists expected a maximum of around 125 sunspots per month, but the Sun has defied forecasts, showing signs it may peak closer to 200. This rise in solar activity increases the probability of solar storms, flares, and coronal mass ejections, explosions that could severely damage satellites, GPS systems, aviation controls, and entire power grids. While the general public may only notice a faint aurora in the sky during such events, these storms have the potential to shut down financial systems, interrupt military communications, and plunge cities into darkness. The incident of 1972 was just a small taste of what's possible. Today, the stakes are unimaginably higher. At Infinity Beyond, we explore this cosmic tension, the balance between the Sun's life-giving light and its capacity for annihilation. In upcoming episodes, we'll delve deeper into solar cycles, magnetic fields, historic solar catastrophes, and what agencies like NASA are doing to protect humanity from the Sun's fury. Because make no mistake, it's not a question of if the next solar storm will strike. It's a question of when. About 4.6 billion years ago, long before Earth harbored any life, a massive molecular cloud of gas and dust began collapsing under its own weight. The collapse wasn't spontaneous. It may have been triggered by shock waves from a nearby supernova or the gravitational influence of a cluster of young stars. Whatever the cause, this cosmic event set the stage for something monumental, the birth of our Sun. As the cloud contracted, it began to spin faster, just like a spinning figure skater pulling in their arms. This rotation caused the cloud to flatten into a disk, a process governed by the conservation of angular momentum. In the center of this disk, matter started clumping together under gravity's relentless pull. This central core became denser and hotter over time, accumulating more material and increasing in mass. Eventually, the temperature inside this core soared into the millions of degrees. That's when something truly extraordinary happened. Nuclear fusion began. Hydrogen atoms collided with such immense force that they fused into helium, releasing staggering amounts of energy. This energy pushed outward, counterbalancing the inward pull of gravity. And just like that, a new star was born. Our Sun. The Sun entered what astronomers call the main sequence phase, a long and stable period where fusion sustains its shine. And it's still in that phase today, but this apparent stability hides the tremendous power it holds. Every second, the Sun emits more energy than humanity has ever consumed in its entire existence. It bathes the Earth in light and warmth, fueling life as we know it. Through photosynthesis, plants convert sunlight into food, sustaining every living being along the food chain, including us. But this nurturing energy is only part of the Sun's story. The same processes that give us light also produce intense solar winds, streams of charged particles ejected from the Sun's corona, its outermost layer. These particles move at tremendous speeds, carried along magnetic field lines stretching across the solar system. The Earth's magnetic field acts as a shield, protecting us from most of these charged particles. But sometimes, the Sun unleashes more than just a breeze. It roars. When these solar winds intensify, they can cause geomagnetic storms, disrupting satellite communication, electrical grids, and even global positioning systems. They also create stunning auroras, lighting up the sky with vivid colors: red from nitrogen, green from oxygen, and blue from hydrogen. These lights are beautiful, but they signal a deeper, invisible force interacting with our planet's magnetic barrier. And there's more. Solar magnetic fields don't stay neatly aligned. The Sun's rotation causes its equator to spin faster than its poles, twisting its magnetic field into knots. Over time, these knots can snap, releasing immense bursts of energy in what we call solar flares or coronal mass ejections, CMEs. When Earth lies in the path of a CEOW, the consequences can be severe. At Infinity Beyond, we're only beginning to uncover how intimately our fate is tied to the Sun's moods. In the next chapter, we'll dive deeper into how these solar storms form and how a single misaligned flare could plunge Earth into a technological blackout. Because this story isn't ancient myth, it's modern science with real consequences. Fast forward to today, our Sun has reached the midpoint of its life cycle, around 4.6 billion years old, and it's currently in what scientists refer to as the main sequence phase. During this stage, it shines stably and consistently, providing a nurturing environment for life to flourish on Earth. However, the stability we enjoy is balanced atop a system of intense and dynamic activity beneath the surface. Activity we are only just beginning to understand. The Sun today is approximately 30% more luminous than when it was born. Its energy flows through the solar system in the form of light and heat, supporting nearly every living process on Earth. It drives photosynthesis in plants, controls weather systems, and ultimately determines the rhythms of ecosystems. Solar radiation is, quite literally, the foundation of all life as we know it. Every bite of food we consume, every breath of oxygen we take, can be traced back to that golden sphere hanging in our sky. But despite its life-giving role, the Sun harbors secrets. Hidden within its surface are volatile magnetic fields and extreme heat zones that can become dangerous without warning. When viewed through the eyes of space observatories, this glowing star reveals an entirely different face. It's not the gentle celestial guardian we imagine. Instead, it's a raging, violent engine of energy, a star capable of producing the most powerful explosions in our entire solar system. Every second, more energy is generated through solar activity than all of human history's consumption combined. Most of the time, that energy flows outward smoothly, bathing Earth in light. But sometimes it becomes trapped and twisted into unstable magnetic loops near sunspots. These sunspots are cooler, darker areas on the sun's surface, but they are surrounded by highly active magnetic regions.